All right, class, in this video, we do example 3 in the related rates applications. And so I can't put the question up on the board, on the whiteboard, but I can show it to you right in the video. So let's read through it together. We're given the demand equation for a certain brand of headphones is 100x squared plus 9p squared equal to 3,904, right? So here's the demand equation, where x is the number in thousands of headphones demanded each week when the price is p dollars. How fast is the quantity demanded increasing? So here so it's asking how fast is something changing? So we know there's going to be a derivative involved. How fast is the quantity demanded increasing when the unit price per headphone is $16 and the price is dropping, which means decreasing, at a rate of 10 cents per headphone per week? So let's define the variables, okay? X is the quantity demanded in thousands. P is the price of each headphone in dollars. And T is time in weeks. And we're to ask how fast is the quantity demanded increasing? Well, quantity demanded is X, right? So it's asking how fast is X increasing when the unit price per headphone is $16 and the price is dropping at the rate of 10 cents per headphone per week. So it's asking how fast is the quantity demanded increasing per week, right? What's the rate of change? What's the derivative of X with respect to T when the price per headphone is $16 and the price per headphone is decreasing, right, dropping at the rate of 10 cents per week? And how we write a negative 10 cents in dollars is minus 0.10. Well, in order to find dx over dt, we need to know what x is. So, and we're not given x. But we have the demand equation, and so we just plug in the value of p in this case, which is 16, and then we solve for x. And so we replace p with 16, so we have 100x squared plus 9 times 16 squared is equal to 3,904. And when I solve for x squared, I get x squared is equal to 16, and then when I take the square root of both sides, I get x is equal to 4. So when the price is $16 per headphone, right, the demand is 4,000 headphones per week, okay? So now that we know what x is, we can calculate what dx over dt is under these two conditions, okay? The price is 16 and the price is dropping at the rate of 10 cents per week. So here's the demand equation. We have to differentiate both sides with respect to time using implicit differentiation. So the derivative of 100x squared with respect to time, bring the 2 down in front of the x, subtract 1 from the exponent, we have 200 times x. But because we're differentiating with respect to time, we got by the chain rule, we got to multiply that by dx over dt, right? The derivative of x with respect to time. And then the derivative 9p squared with respect to time, bring the 2 down front, subtract 1 from the exponent, and we end up with 18 times p. Because we're differentiating with respect to time, by the chain rule, we got to multiply that by dp over dt, derivative of p with respect to time. And on the right-hand side, the derivative constant, right, derivative constant is always 0. So now we can plug in for x, p, and dp over dt. X is 4, p is 16, and dp over dt is minus 0.10. And now we just got to do the arithmetic to solve for dx over dt. 200 times 4 is 800, and 18 times 16 times a negative 0.1 is minus 28.8. So I need to do a little erasing, and we can finish solving for dx over dt. So I add 28.8 to both sides, right? And I have 800 times dx over dt is equal to 28.8. And now I divide both sides by 800, and I get dx over dt. The rate of change of quantity demanded with respect to time is equal to 0.036 something per something, right? Well, x is in thousands, so this is 0.036 thousand. What per what? 1,000 headphones per week. So the rate of change of the quantity demanded, okay, is 0.036 thousand headphones per week. And so if I multiply 0.036 by 1,000, I get 36. So it's 36 headphones per week. So when the price is $16 per headphone and the price is decreasing at the rate of 10 cents per week, the quantity demanded is increasing at the rate of 36 headphones per week.